Well, hello there guys, Mr. G here, and we are going to be doing, as promised, the lesson of revision about collisions. So this lesson is revision about collision, and we're going to start with the first question. Now these questions, remember I always post the question in the community for you to try and do the questions before watching the video. Even if you don't see it in the community, try to go to the comment of the video in the description of the video, and then I also post the questions. The idea is for you to do the questions before watching the video. The video is just like a guide to see if you solve it correct. But anyway, let's go to the first question, and this question says two children are playing with toy cars. Car 1 has a mass of 300 grams and car 2 has a mass of 350 grams. The two cars collide heads on and stick together. Note, they say that they collide, but they don't say what type of collision there is. Question 1.1, calculate the final velocity of the car after the collision if car was traveling at 5 meters per second and car 2 was traveling at 2.5 meters per second. So here is a car 1. So this is referring to car 1. Let's fix that one quickly. Okay, there is fixed. And then 1.2, identify the type of collision by means of calculation. So for the first one, before we carry on, let's try to do the drawing of what is happening here, a quickly sketch. Okay, so this is the picture of what is happening. We have a car 1 with the mass is going to be 300 grams. So let's write the data here. Mass 1 is equal to 300 grams. You don't work in grams, you work in kilograms. So this is going to be equal to 0.3 kilograms. And then you have a car 2, which the mass is equal to, mass 2 is equal to 350 grams, which is equal to 0.35 kilograms. The two cars collide head on and stick together. So they're going to move together. After they are moving together, and note that I wrote they're moving because I don't know the direction in which they are going to be moving. I just find out they are moving together. Calculate the final velocity, and velocity, remember, is a vector quantity, so it has direction. Alright, so we have to give a direction when we give the final answer. After the collision, if car 1 was traveling at 5 meters per second, so the velocity 1 is equal to 5 meters per second, and the velocity 2 of the second car was 2.5 meters per second. Velocity 2 is equal to 2.5 meters per second. I'm not going to write the direction because it is shown by the arrows there. Okay, so calculate the final velocity of the cars after the collision if car 1 was traveling. So we have to look for the calculation after the collision. Now, to do this one, guys, we have to apply the law of conservation of linear momentum. We cannot use conservation of kinetic energy because we don't know if the collision is elastic or inelastic. So I'm going to fast forward the solution for this part because it's been done in many videos. Please go and watch the videos. I'll leave the link there. Is the velocity of the two cars moving together. So let's go to the next question, and the next question say identify the type of collision by means of calculation. Now all we have to do is to calculate the total kinetic energy initial and the total kinetic energy final. If they are equal, that means that the collision is elastic. The total kinetic energy initial, and that is, remember, the addition of kinetic energy 1 initial 1 plus the kinetic energy, let's keep the same symbol, kinetic energy initial 2. Okay, so I'm going to show you because in the previous video, watch, I'm going to put you a link, then you can watch how it's done. So I'm going to just substitute fast forward and you will see the answer. Okay, and here we are. So this is the answer for the total initial kinetic energy. This is the answer for the total final kinetic energy. So now we can write the conclusion. Therefore the total kinetic energy initial is not equal to the total kinetic energy final. The collision is inelastic. And this is the first question we are going to do. I hope you understand it's not that difficult and we did practice before. Okay, so that is the answer for the first question. The advantage to have videos is that you can stop, fast forward, backward, you can reverse, etc. Now, the second question we are going to do is a little bit more challenging. Now, this question was a question 4 from June 2015, the senior certificate. The question says two stationary steel balls are A and B are suspended next to each other by massless inelastic string as shown in the diagram below. So there is the diagram, you have ball A and B, and they are just hanging from the roof of somewhere. So ball A of mass 0.2 kilogram is displaced through a vertical distance of 0.2 meters as shown in the diagram below. When ball A is released, it collides elastically, and that is an important thing here. The collision is elastic and head on with ball B. Ignore the effect of the friction. Now, let's explain something quickly here. This is going to be ground level. This marks here where ball B is going to be ground level. Okay, so we're going to have that one in mind. Now, 2.1, what it means by an elastic collision. Now, what is an elastic collision? We can somehow answer that question there. An elastic collision is a collision where total kinetic energy is conserved. That is what we call elastic collision. We cannot say that momentum is conserved because momentum is conserved in both type of collision. So it doesn't really matter. In this case, you'll have to say that it's a collision where the total kinetic energy is conserved or is constant. If you want to be more general, you can say that both kinetic energy and momentum is conserved, but because momentum is always conserved, it does not make a change here. Now they say immediately after the collision, ball A moves horizontally backward. So ball A is bouncing. Ball B acquire kinetic energy of 0.12 joules and move horizontally forward to the right. Calculate the kinetic energy of ball A just before it collides with ball B. Use principal energy. Now this one here, this question here means that you cannot use kinematics, you cannot use equation of motion, you have to use a principle of energy, and in this case we're going to use the law of conservation of mechanical energy, which also there is a video on that one, was a question similar to this one that I'm not going to explain. I'm going to fast forward and I will give you a link so you can watch that video in case you don't remember. Now, they have a look for ball A. Remember, we're working for ball A. So I'm going to draw here only ball A. Now what we have, the ball was moved in that direction as is shown in the picture there, and it's dropped. It means that the velocity of the ball when it's at this point is going to be 0 because it's been released, and they're asking you to calculate the velocity at this point, which we are going to call final velocity. All right, so that you need to know. The height is going to be 0.2 meters. And that is only for ball A. And that is the answer for the first question. They asked the kinetic energy of ball A when reached that specific point, which is just before hits ball B. Now they also ask you to calculate the speed of ball A immediately after the collision. Now, in this other question, to calculate the speed of the ball immediately after the collision, because the collision is elastic, they say it there, it's an elastic collision on top, we can use either conservation of momentum, or we can also use conservation of kinetic energy, which is the one we are going to use here. This is question 1.3, and we are going to use conservation of kinetic energy because that is the idea of this equation here. Okay, so we have that the total kinetic energy initial must be equal to the total kinetic energy final. Okay, and that means that is the total kinetic energy initial. This is the total kinetic energy initial of ball A plus the kinetic energy initial of ball B, and this is equal to kinetic energy. Let's write the same symbol. Kinetic energy of ball A final plus kinetic energy of ball B final. All initial is equal to all final. They said that the collision is elastically. That's why we can do that. Now, the kinetic energy initial of ball A is given to us. It was calculated. It was calculated just here on top. Okay, so this one would be 0.392 plus kinetic energy of ball B is 0 because the object of ball B is at rest, is not moving. Kinetic energy final of ball A, we don't have it. We can substitute its formula, mass and final speed A square plus kinetic energy of B immediately after the collision is given to us and is equal to 0.12. Now if we substitute that side, we have that 0.392 minus 0.12 is equal to half. The mass is 0.2 multiplied by speed final A to the power 2, which is the question, and the final answer here would be 1.64 meters per second. And they asked to calculate the speed, so the final answer is without direction because speed is a scalar quantity and you don't have to give a direction. So this is the answer for 1.3. And then the final answer here, the final question said or asked, calculate the magnitude of the impulse of ball A during the collision. Now, to calculate the impulse, we must remember 1.4, question 1.4, we must remember that impulse, I'm going to write that on them, is going to be equal to the change in kinetic energy. We're working with ball A, so everything is for ball A. And this is equal to mass multiplied by the final velocity A minus mass final velocity, initial velocity A, and we don't have the initial velocity A, we only have the kinetic energy initial of A, which was calculated right there. So to say that, we can calculate the final or the initial velocity of ball A, and let's quickly do that. The kinetic energy of ball A is equal to half mass speed to the power 2. The kinetic energy is given to be 0.392, and this is equal to half multiplied by 0.2 and the velocity or the speed to the power 2. If you calculate this one here, the answer is going to be for the speed equal to 1.9798. Let's round off properly here. It will be 98 meters per second, and that is what you substitute in there. Okay, now we must keep in mind the direction we select as positive at the beginning, which was that direction there. And then if we substitute, we have that the impulse is equal to 0.2 multiplied by the final speed, which is in the opposite direction, and equal to 1, minus 1.64 minus 0.2 multiplied by the initial speed, which is 1.98, and the final answer for the impulse is going to be equal to 0.7 2 newtons second. And the answer is positive, which means it is to the right. But the question only asks for the magnitude, so this is all for now. Now, this is the question, the second question, the final question on this video. Is a little bit more challenging, but it's not that difficult. Remember here, it said the direction to the right as positive at the beginning here. So if that direction was positive there, that is why the initial was positive here. It is the one, and the final is negative. Okay, so I hope you understand, guys. Ask questions, you can suggest, subscribe for the channel. I'll see you next time. We're going to be solving another question, the last question of this topic for now, which is going to be a little bit challenging, and I'm going to try to do the experiment about conservation of momentum next video after the other question. Thank you for watching. I'll see you next time. Mr. G here.